Then that's where I've included the most frequently missed problems from this quiz, which I'll go over. And then when I'm done with that, we can work on the quiz, not the quiz, sorry, the that test review packet if you worked on it over the weekend. I have it up here. We can go over anything you want to go over. So, all right, first one of the most frequently missed on the quiz. What is the x-intercept? And all of these multiple choices were worth 3 points. So that's how we got to the 36. 12 times 3. What is the x-intercept of the following function? How do you find x-intercepts? 4 for y. So 0 equals 2 to the x plus 3 minus 16 plus 16 on both sides so that we can isolate the base. Once the base has been isolated, how do you remove the base? Take the log of the same base. So take log base 2 on both sides. That cancels out. On this side, you need to evaluate the log. You can either do common base or the more popular change of base. Log base 2 of 16 is 4. That equals x plus 3. Minus 3 minus 3. But then to also make sure that you're paying attention, you got to remember this is an x-intercept. So they have these all written as ordered pairs. Which one is a point that falls on the x-axis? Well, it's not A, but yeah, the first one listed here. Don't be distracted by this one here. That would have been if it were a y-intercept. It's x comma y. So, any questions there? And you can write in this packet I just gave to you. It's yours to keep. Haven, you're working on my stuff? I see other things that I didn't give out there as well. Describe the transformations of the parent function onto this new one. So we don't even really care about what this is. We just care about over there. Let's identify A, C, H, and K. This is similar to the first one from the free response. What's A here? 2, what's C? 1, what's H? Negative 6, and what's K? So how many total transformations are there here? Oops, sorry, I got it. Yeah, there's 3. What's A doing? Yeah, a vertical stretch by a factor of 2. C's not going to do anything. What's H doing? It's a translation 6 units to the left, and then a translation 2 units up. So which one of these says those? The fourth one, left up 2. Yep, very good. When you took it, it shuffled the answer choices, so it might have not been the fourth one when you had it on yours. But wherever that was on yours, that's the one you had to pick. Any questions there? Oh, another thing also, just for speaking, because all the people not being here just reminded me. This is not a Romero thing. This is an Algebra 2 thing, but it looks like the consensus now going forward is if you're absent from a quiz, you're gonna have to make up the points on the test. That they're not gonna be makeups offered on quizzes. So just make sure you're here. Like you'll get it's not gonna stay at 0, but instead of making up the quiz, it'll just have to come from the test. The test will have to count double. All right, find the domain and range. Okay. So what do domain and range depend on when it comes to exponentials and logs? What would be the biggest determining for, like, what would, I don't know, Yeah, there you go. I was trying to figure out a way to word it, but yes, the asymptote. What do we know about logs? Yeah, like regardless of, as long as it's a logarithmic, we know the range is going to be all real numbers. But the domain is going to be affected by the asymptote. Typically, most logarithmic functions are to the right of the vertical asymptote. The only way that would change that is if, like, what causes y-axis reflections? No, A does not cause y-axis reflections. C, yeah, if C were negative. So yeah, this one is going to reflect. It's going to flip, but it's just going to flip this way. It's still going to be to the right of the asymptote. And where is that asymptote? Where is that vertical asymptote? It's at -2, so we're going to go from -2 to positive infinity. And that would be A, which is this one up here. Victor, my homeboy. Some people might look at this and say, hey, look, they put the exact same thing twice. This is crazy. What's the difference? If you put a bracket, what does that imply? Yeah, it implies that the function touches that point. But does a function touch where an asymptote is at? Au contraire, so no. I don't think these were shuffled for you. The ones that had A, B, C, D, I think it was the same order for. You know that you can zoom in, right? You feel old. Oh, did I cut something? That's good. I feel old every day. Use the graph below the. Okay, so here's the domain and range also, but at least now you get to see a picture of it. What's the domain going to be here? Or better yet, let's take a step back. What type of function is this? Exponential. How do you know it's exponential? Oh, look at Randy. Good. The asymptote's horizontal. So the domain is going to be. The domain is going to be all real numbers. How about the range? From 1 to positive infinity. So let's see which one of those says that. Domain all real numbers. But it's not going to touch 1, so it can't be B. So it looks like it would be D. These are just the ones that were missed the most. Use the graph to determine the transformed function of f of x is equal to e to the x. Okay. So this is exponential. They just want to see what type of transformations occurred. Okay. What would be the easiest one to determine? Yeah, the asymptote. It's going to be at 2. Now the other ones can be a little bit tricky. You'd have to do what's called a regression, which is like it requires the use of algebra unless it's structured like this, like multiple choice, where you can kind of use process of elimination. Like here, why can't it be A? A is negative here. That would have meant that you would have flipped over the x-axis, and that didn't occur. It's staying above. Why can't it be B? The asymptote is not at 3, so it can't be that one. Yeah, the whole point is that you're not expected to know how to do a regression. Why can't it be C? Again, there's no x-axis flip. D looks pretty good, at least on the surface. I don't see anything there that would disqualify D. What's wrong with E? Wrong asymptote and a flip. This one has wrong asymptote. So I didn't have to really get in depth and analyze the points or anything like that. The only one that it could be is D. And if that were the case, A and C would have been 1, and the only other thing is that we had a horizontal shift 3 units to the left. Any other questions? All right, use the graph below to describe end behavior. Fun. What type of function is this? Logarithmic. So I want to see what's happening at each of the arrows. What's happening at the right arrow? What's happening at the left arrow? Okay, and we want to know what's happening there with respect to each axis. Let's start with the left arrow. Where is the left arrow headed with respect to the x-axis? How far left does it go? To 1. And when it goes to 1, what's y doing? Yeah, negative infinity. So we know it can't be this one. So far that second one looks okay. X is not going to negative infinity, so they can't be this. Wow. So okay, I didn't even need to look at the right arrow, and I've already eliminated. It looks like I already found the answer, but let's just for the sake of, just for fun, let's look at the right arrow. With respect to the x-axis, what's the right arrow doing? Yeah, it's going forever to the right. And with respect to the y-axis, what's the right arrow doing? Also positive infinity, both infinities. So B. Hey, Mohammed. Any questions? Last one from the multiple choice that was missed the most. Use the graph below to determine the transformed function of L of n of x. So ln of x just is the same thing as saying log base e of x. So this is a type of logarithmic function. It looks like a flip occurred because what type of base is e, like approximately? Well, it is greater than 1, but it's around 2.7. So when you just take the regular log base e, like anything that's greater than 1 should look like that. So if it's going the other way, it looks like a is going to have to be negative. What else can we tell from looking at it? Yeah, the asymptote is -3, so a should be -3. And we're not too sure about the other ones yet, but let's see if that's enough to narrow it down. Remember, the asymptote is -3, so why can't it be a? Well, yeah, that even though you see -3, that means this asymptote is +3, so it can't be there. B looks good, but what don't we see on B? Yeah, there's no flip here, so it doesn't look like it'll be that one. C looks good. It has a flip and it has the -3, so far that's fine. D has the wrong asymptote, and it has no flip. And it looks like the same thing for E and F. Wrong asymptote. Both of them have flips, but they have the wrong asymptote. So the only one that it can be is C. Okay. And then now finally the free response. Both free responses were worth 7 points. You had 3 points for the transformations, 4 points for the graph. Okay? 7 points each. So if you got anything less than that, then that's because something was wrong. All right, so first let's describe the transformations. A, C, H, and K. A is? Ali Shan, what's A? Good, -1. C? H? K? How many total transformations am I going to have here? 3 total ones. All A is doing is an x-axis reflection. Now, see what happened. These are tricky things to grade because some of you put extra, like not a lot of people, but some of you put the correct transformations, but then also put extra transformations that weren't there. Like, oh yeah, a stretch of 2. No, there's no stretch there. So what I did is, if you put anything extra that wasn't there, I took away one of the points from something that you had put correctly. So that could be why you have the right answer, but then also not have the full points. There should only be 3. X-axis reflection, translate 1 unit right, and you need to put a magnitude. You got, not to say translate right. You got to tell me how far. And then translate 3 units up. If you put horizontal translation 1 unit right, even better. If you put vertical translation 3 units up, even better. But by putting the words right and up, that already implies, horizontal or vertical. And it was just obviously 1 point each. 1, 1, 1. Any questions there? Then for this next one, there was 4 points. You got 1 point for the asymptote. This is exponential, so we have a horizontal at 3. Even if you did nothing else, and sadly there were some people that did nothing else. This is all they did. They learned how to put an asymptote, and that's all. But that's fine. If you, as long as you put an asymptote at 3, you got a point. Okay, that was 1 point for that. Then the other 3 points came from properly plotting points. I wasn't too strict with the work. I could have been a lot more strict with the work. At least you had to show. I know a lot of it comes from the calculator, but I would have hoped you would have at least shown me something. Either the table that I showed you or using coordinate notation. I don't know. You tell me. Does anybody have a preference? You want me to use the coordinates or you want me to use the table? The table? Okay, so let's do the table. Let's go like this. All right, so we need to get the x's, and all of the x's, all that's going to happen is we're going to add 1. And then we're going to get the y's, and we're going to go times -1, and then +3. The base here is 2. That's going to tell us what points we start with. I needed to see at least 3 points. So 0, 1, 2. If you put an extra point, even better. But 3 points would have sufficed. 1. So 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. Here, I'll put an extra point just in case some of you did, just to make sure you got it right. 2 to the third is 8. So if you add 1 to all the x's, we get 1, 2, 3, 4. If we multiply by -1 and add 3, this becomes 2, 1, -1, -5. So 1, 2, 2, 1, 3, -1, 4, -5. All you needed were 3 of those, and that would have been 1 point each, for a total of 4 points. You okay, Cade? Rough game this weekend. Kid from North is pretty good. I see you. Yeah, it's a nice low-scoring game. Some good old National League baseball. All right, and now there's no question on the first one. Okay, so now the second one, same structure. 3 points for the transformations, 4 points for the graph. Let's identify A, C, H and K. What's A? What's C? The difference is this logarithmic. But what's H? -4. K? -1. So what's the first transformation? Vertical stretch of 2. You have to put the word vertical. You have to put stretch. Stretch. You can put by a factor of 2. I'll just put up 2. That's fine. Vertical stretch of 2. What else? Translate. 4 units left. Another issue. You gotta put the word translate. Now, if you put shift, slide, okay, fine, I can deal with that. But you gotta tell. Some people just put 4 units left. Well, what do you want me to do for? Do what? So, and that's even a geometry thing. Like last year when you guys had geometry, I know you also worked on transformations. You're letting everybody smell your Post-it? Have you ever smelled those like scented markers? Those like Mr. Sketch scented markers? Those are the best. Translate 1 unit down. So those are your 3 points there. Okay. So depending on what you put there, the maximum was 3 points. The maximum here was 4 points. Again, you got what should have been a freebie, as long as you know that logarithmics have a vertical asymptote. If you correctly put that vertical asymptote here at -4, that was 1 point. If you did nothing else, that was just 1 point just by doing that. But now let's try to come up with the points. I guess you want me to do the table again. What was the trick I taught you for the table? Put the inputs on the y. Now this is a base 3 log, so I still want to use 0 and positives. 0, 1, 2. You only need 3 points. I'll put 4. And then now we can treat it exponential. By doing that, we can treat it exponential. We don't have to worry about logs. 3 to the 0 is 1. 3 to the first is 3. 3 squared is 9. It is 27. Once I have these starting points, now I want to get all my x's and subtract 4. And I want to get all my y's times 2 and then -1. So this gives me -3, -1, 5, and 23. That one's going to be too big to fit. Times 2 so there's -1, 1, 3, and 5. I'm just going to fit the first 3. -3, -1 is here. -1, 1, 5, 3. And since we know how asymptotes work, just make it hug the asymptote. And those are your 4 points there. Any questions? All right, so for the last 15 minutes or so, no, more, no, 25 minutes. Oh, I can't tell time. Yeah, 25 minutes. We can go over this test review packet, which I gave you. It's not for a grade, but did anybody actually work on this over the weekend? No? So nobody has any requests to go over first? I can just pick and choose as I wish. All right, so if that's the case, then let's work backwards on this. Not because I expect these to show up anymore tomorrow, just because I think these are the ones we've least worked on. Like I just did a bunch of graphs. Let's do this page first, and if there's any extra, then maybe we can just do like an E and LN one. The domain of a logarithmic function is from 8 to positive infinity, what is the domain and range of the inverse function? Okay. What is the inverse of a what's the inverse of a logarithmic function? An exponential. And we already know that an exponential has a domain of all real numbers. But now since they gave us the domain of the logarithmic, that domain is going to become the range. And it would be 8 to positive infinity. Since they're inverses of each other, you just swap the domain and range. What is the domain, range, and behavior of this function here? What type of function is that? Exponential. So the easy one should be domain. What's the domain there? All real numbers. Cade, what's the range going to be? You notice how I didn't say anything to him, right? Like I didn't reprimand him for giving you the answer. That's probably telling you something. He's wrong. What do you think, Tommy Boo? Very good, because if you look out in front, A is negative. This had an x-axis reflection. So, yes, we have a horizontal asymptote, but where this used to be an exponential growth, it flipped over that asymptote. So the range is going to be from negative infinity up until negative 6, since A is negative. And I guess while we have this up, let's just leave it up then maybe to help you focus on the last part, which is the end behavior. What's the left arrow doing? What's the left arrow doing? Remember, the asymptote's up here. So what's the it is, yeah, it's going to go to negative infinity. And look, and it's exponential. The right arrow is going to go to positive infinity too. It's not doing anything. But then how about the right arrow? I'm sorry. How about the left arrow with respect to the y-axis? What's the left arrow doing? Yeah, it's going up to the asymptote at negative 6, and the right arrow is going to negative infinity. Another thing you might want to pay attention to, if you look at all those values, where else do you see them? Where else do you see two negative infinities, a positive infinity and a negative 6? Where else on the screen? Yeah, if you look at the domain and range. So maybe that'll help you catch some mistakes. Now Cade's going to totally redeem himself. Domain, range, and end behavior. I'll give you the easy ones, Cade. Let's start off with domain and range. What's the domain here for this log? Nah, it is not. Gabby, domain? Yeah. Yeah, sorry. Thank you. Negative 4 up until positive infinity. Whoa, Mr. Romero, isn't there a reflection there? Yes, there is. It's an x-axis reflection. Logarithmics have a vertical asymptote, and whereas this being a base 2, like that it's bigger than 1, It's supposed to look like that, but now it's gonna look like that. Well, whoopity do. It's still on the right side of the asymptote. The easy one should be the range. What's the range gonna be? Fact. Bet. And then finally, and behavior. Now remember this flips, so we're really looking at, it's gonna look something like that. What's the left arrow doing? It's going to the asymptote with x. What's it doing for y? Huh? It is going to positive infinity. What's the right arrow doing? For x, it's going positive infinity because it's going to the right, but then for y, it's going down to negative. Where else do you see two positive infinities, a negative infinity and a negative 4? Yeah, the domain and range. Now, what the domain and range are not going to tell you is which one goes with which, but those should match. Well, because you don't see like, you're saying what now? Where the x goes, it's gonna be on the domain. Yeah, okay, yes. Like, so you will know that for the end behavior, this is gonna be one of the x's, this is gonna be one of the x's. But what you don't know is which y is gonna go with which. Because like this negative 4 went with this positive infinity, and then this positive infinity went with this negative infinity. Yeah, you don't know which is gonna. But yes, you are correct. Yeah, these will be both of the x's, and these will be both of the y's. All right, a little bit easier. What's the asymptote? Go ahead, Cade. What's the asymptote here? No, you still don't know what that means when you see the word log? No. Okay, it is vertical. That's good. Yes, vertical. So means what are we gonna start with? Because it's vertical, what's it gonna start with? What's it gonna start with? Like I'm asking you for an equation. You remember what happened last time you relied on Randy, right? Here, go ahead. We'll just go to Randy. Go ahead, Randy. Anybody want to help Randy out? And x equals -2. Yes, the -2 part was correct, but the x equals is what makes it vertical. How about the next one, Cade? Stop asking me. Didn't you get the hint when I got it wrong the first 3 times? Jeez Louise. You want me to ask Stephanie? Stephanie, you want to help him? Give me the asymptote there. See, Stephanie didn't have a problem with it. All right, matching. Match each graph with its correct equation. In this type of structure, what's the first thing I'm looking at? The asymptotes. These have 2 horizontal and 2 vertical. So I know the ones that are vertical are going to end up being logs. The 2 that are horizontal are going to be exponentials. Once you know that, and then we can take a step further. Like this one looks like it reflected. Like this looks like it's going to have an x-axis reflection because it flipped over the asymptote. Even though it doesn't even look like you're going to need that because every asymptote is unique. Unique, New York. All right, let's look at the exponentials first. So the ones with the horizontal, one of them should have an asymptote at -3, and the other one has it at 1. So the one that has it at -3, this is B, and this is C. Notice how C also, wait, no, not C, sorry. D. Notice how D also has that x-axis reflection. Caitlin, Wen, how about the logs? The one on the top left, which one is that one going to be? Since it has a vertical asymptote at 1. Yeah, that is going to be A. So here's your vertical asymptote at 1, which would mean this last one here is C. All right. Here, let's go down here. Write a logarithmic function with a translation left 3 units, a reflection over the x-axis, and a translation up 5 units, and a vertical compression by 1/2. All right. So that means A, C, H, and K. What would A be? Under this scenario, what would A be? And not only would it be negative, what else would it be? Negative weight. Yeah, -1/2. What would C be? Yeah, they don't mention anything with C, so that's going to be 1. What would H be? -3. -3. You're going left 3 units. What would K be? +5. They don't tell us what base to make the log, so we can just say y equals negative, and it's logarithmic, yeah. So -1/2 log. We don't have to worry about a C, but with logs, you always use a parentheses afterwards, unless there was no C and no H. What's gonna go in the parentheses? Ali Sean, what's going in the parentheses? No, x plus 3, good. And then close the parentheses +5. The only thing that could vary, even though none of you did this over the weekend, the only thing that would vary if you would have done this on your own is the base of the log. They don't really say what base the log has to be, so it could be whatever, base 2, base 3. What base did I choose here? Huh? Yeah. How about this? If I would have written this, would I be wrong? Nope, because it doesn't say what base. What base is that? E. Yeah, with ln it's just base E. Write an exponential function with a stretch by 4, and it doesn't even tell you which. All right, you know what? Forget these things. Well, here. I hate these instructions. Let's assume that this is a vertical stretch. You can write that in if you want, then, and then a translation down 1 unit. If that were the case, if that was vertical, then what would A be? 4. What would C be? 1. What would H be? 0. Good. What would K be? -1. So they want this to be exponential. So y equals 4. They don't tell us what to make the base. The base could be anything. It could be a growth, a decay, could be E even. Let's just do like a base of 2. And then there's nothing horizontal, so X, and then, so there is some variety as to what it could look like. If they don't tell you the base, yeah. I would guess that this would be more likely to be a multiple choice on the test. This wouldn't be likely to be a free response. So like, kind of what you saw in the quiz. Remember you saw in the quiz where they, you know, what are the transformations? Well, instead of you picking the transformations here, they're giving you the transformations. They would probably give you like a group of functions, and you have to say which is the only one that it could be. just to show people that it could be you weren't listening, I put log first, and then I'm like, oh, if I were to put ln, would I be wrong? Nah. Here, this is for you, Moosey. There you go. Even though now it looks like lag, but that's okay. How about this? Just to really mess with Moosey. If I were to do this, would I be wrong? No. Still exponential. All right, the last one. Now this one does say natural log, which doesn't make the first one wrong, but it just says that here this one has to be ln a oof, a c h k. What's a here? A is 1. Good. What's c? -1. It's a y-axis reflection. What's h? +2. What's k? Excellent. So now y equals, I don't have to worry about an a. This is an ln. The negative, well, technically that's supposed to be in its own parentheses. So let's do this, because then it could look like. But that would have to be factored out. There's a negative from C. What would be inside the innermost parentheses? X with what? X minus 2. Close, close, and on the outside, -6. If you don't put that outermost parentheses, you can, whatever, fine. Because then if not, it doesn't look like ln of negative. It looks like ln minus. Yeah. Yeah. That's news to you? Man. Let's do number 3 here, because I think before this is the only type of graph we haven't done is an ln graph. And then that'll be it. A, C, H, K. What's A here? 1/2. What's C? H, K, 4. So list the transformations. This is independent of it. And it doesn't matter what type of graph it is once you've identified the transformation values. Yeah, vertical. I don't have that much space, so I'm going to just abbreviate. Vertical compression of 1/2. And then translate 5 units right. I'm sorry, left. Sorry, but thank you. Yes, 5, but it's 5 units. Somebody said 4. Translate 5 units left. And then try 4 units up. All right. Let's go ahead and do the graph before we do anything else. We're gonna have a vertical asymptote because ln is a type of log at -5. Why is it doing that? It's all your fault, Randy. All right. But as far as the points go, anything involving E and ln, you're gonna have to use a lot of calculator. Let's just do 3 points, and maybe we can fit them up here. What's the base of an ln of a natural log? E, and E is greater than 1, so I would just use 0. Let's just use 0, 1, and 2. All the x's are going to be minus 5, and the y's are going to be times 1/2 plus 4. E to the 0 is 1. E to the first is 2.7. What was E squared? Where's Zora with my calculator when you need her? E squared. 7.38, so 7.4. So minus 5 is negative 4, negative 3.7, and then this is 2.4. 1/2 plus 4 is 4. This is 0.5, 3.5, and this is wait, that doesn't make sense. Plus 4, 4.5. This should be 4, 4.5, and 5. So negative 4, 4, negative 3.7, and 4.5. Like right around there. Ooh, it's tight. And then 2.4 and 5. So it looks something like that. It's compressed. The asymptote would be x equals negative 5. Maybe let's just see what we haven't talked about today. How about, is it increasing or decreasing? It is increasing throughout its entire domain, the domain being negative 5 to positive infinity. We did find an x-intercept today. You would find the x-intercept by making y equal to 0. It looks like it's going to cross the x-axis somewhere just before negative 5. And then how would you find a y-intercept? Yeah, x0. It looks like it's going to cross at well, my graph is off a little bit. It should be a little bit underneath the 5. All right, we'll leave it at that.